viruses are really peculiar entities. They appear to exist solely for the sake of reproduction and straddle the living and non-living divide. Often hundreds of times smaller than bacteria, they are merely DNA or RNA strands covered in a barrier. Every sort of cell-based life on the planet can become infected because there are millions of distinct varieties of viruses. And there are around 10 times as many of them as there are other living things. After hearing so much lately about the coronavirus, I began to consider how a space environment would impact viruses. Can viruses endure in outer space? Could the Earth's life forms contaminate a planet once a spacecraft lands there? How do people in space respond to illness? Are alien germs that easily infect a host with no immunity something that may actually happen in a War of the Worlds scenario? I'll start by answering the initial queries. If viruses or bacteria are able to live in space on a spaceship, we may potentially be contaminating Earth-based life forms onto other planets. A clean room is frequently used during the construction of a space probe to prevent dust from harming the delicate machinery. Additionally, it is to minimize the possibility of contaminating the probe with terrestrial life. Germs on board won't be a major concern if the spacecraft is only going into an orbit above Earth, since even if the spacecraft was contaminated, there is a good probability that the satellite will fall back to Earth eventually. However, before they are launched, probes traveling further out must pass through a considerably more rigorous sterilizing process. Each component will be carefully sanitized using alcohol wipes during manufacture. The probe is next subjected to a procedure known as dry heat sterilization, which involves heating it as much as possible for 30 hours, up to a maximum temperature of about 120 degrees Celsius. However, if the equipment on board are too sensitive for such high temperatures, this strategy may not always be an option. Other approaches are accessible in the situation. The ultimate objective of these procedures is to lower the number of bacterial spores on the surface to less than 300,000 because it is virtually impossible to entirely eradicate all microbes. Polyextremophiles, a class of highly hardy bacteria, are known to be resistant to a variety of sterilization techniques. So even after sterilization, they might still be present on the spacecraft. Therefore, after launch, it's possible that bacteria on the spaceship survived the entire journey and are currently in space. But can they endure there as well? Because otherwise the initial sterilization procedure would be useless, scientists obviously believe they can. The survivors now need to be able to withstand ultraviolet radiation, freezing temperatures, and space vacuum. The probe would then need to locate a habitat to begin breeding on once it reached the extraterrestrial world. Could this thus have already occurred? Maybe, even though scientists believe there is only a 0.01% probability that we have contaminated another globe, or in other words, that panspermia through forward contamination has occurred as a result of all these events. How about a virus? Since they are damaged or destroyed quickly without a host, viruses aren't actually regarded alive when they aren't within a host cell. Even in ideal conditions, most viruses can't survive for more than a week without a host, let alone in the harsh environment of space. Therefore, if a probe's surface was free of bacteria but still contained a few viruses, those viruses wouldn't survive very long in space. But what happens inside a manned spaceship is a very other story. Humans require a more similar environment to what we experience on Earth than robotic, autonomous space missions do. It should come as no surprise that bacteria and viruses thrive in this environment as well. The launch process, 0G, and the artificial habitat all increase astronauts' stress levels, even if they are quite skilled at managing with it. Humans aren't really built for being in space. According to a recent NASA study, the astronauts' bodies' elevated stress caused dormant herpes viruses to awaken, as seen by a sharp increase in the frequency of herpes viruses shedding, that is, trying to find new hosts in their urine and saliva. Oral, genital, shingles, and chickenpox are herpes viruses. The fact that stress influences viral shedding is not particularly surprising, though, given our immune systems function much better when we are not under stress. However, it does imply that bacteria and viruses are now replicating and thriving on the ISS. However, there are numerous filters on board that clean and recycle the air, reducing the likelihood that these viruses would spread and infect the entire crew. The study claims that viruses reactivate more frequently the longer the spaceflight lasts. This is yet another aspect to take into account while planning a lengthy space mission to transport people to Mars. Immunizations against the viruses would be one way to address this. However, as of right now, there is only a herpes vaccine for chickenpox. We have discussed panspermia through forward contamination or the introduction of germs to extraterrestrial worlds. If we ever send humans to Mars, something that, if it hasn't already happened, will undoubtedly happen. What about back contamination panspermia, though? Is it possible that alien germs or viruses are now thriving on Earth, or even if they aren't, is it possible that they will in the future? Let's rule out the notion that extraterrestrial spacecraft have already visited our planet. Let's only concentrate on asteroids and comets, two things we understand a little bit better. Currently, various missions have been carried out that have closely examined asteroids and comets. Some of these projects, like the ESA's Rosetta mission, unexpectedly discovered sophisticated organic molecules on the surface of the comet. Substances like amino acids and nucleic acids, which serve as the basis for DNA and all life. We still don't know for sure whether there are extraterrestrial bacteria on comets because none of these expeditions had specialized tools that could detect life. However, I should point out that despite the discovery of complex organic molecules, there is still a huge gap between organic chemicals and even the most basic life forms. Simply put, according to scientists, a comet or asteroid cannot offer the conditions necessary for the emergence of life as we know it because they lack an atmosphere, liquid water, and solar protection. Let's assume, though, that life can be found on these objects, and that some of them made it to Earth after falling and entering the atmosphere. Could an invading species pose a serious threat to us? The likelihood of that is extremely remote. The ability of viruses to infect creatures with whom they have developed and adapted is good. They are built in very specific ways in order to enter and infect very particular cells. Let's use a simple illustration. If the extraterrestrial virus species were far larger than conventional Earth cells, they would not fit into most cells. And that's assuming that these viruses also propagate by DNA or RNA. In a different environment, they may have developed a whole other system, making them incompatible with life on Earth. However, it should be noted that probabilities are a major topic in this discussion. NASA's policy says that these samples will be quarantined and thoroughly analyzed, even if the risk is low, should we ever transfer samples from Mars back to Earth. This is done to lower the possibility of any back contamination. They are obviously not dismissing the concept, then. Only a small percentage of scientists are certain that back contamination occurs and will continue to occur. In fact, it was argued in a report published in Nature titled An Overprotection of Mars that there was no need to sterilize spacecraft as Mars and Earth have been trading space pebbles for millions of years. This is a reference to meteor collisions that launch debris into space, some of which ultimately land on the nearby planet. Therefore, even though panspermia is thought to be extremely implausible, we can't actually prove either way just yet. Therefore, I would be really curious to know what you think about this in the comments section below. Thank you for viewing. Make sure to subscribe if you want to see more content similar to this so you won't miss any upcoming releases. And I sincerely hope that everyone stays safe during this trying time. Best wishes, and I'll see you later.